This section of the tutorial presents instructions for installing Trident in a Kubernetes cluster and configuring Trident with 2 storage backends. The most straightforward way to launch Trident would be to use the installer bundle that you can find on Trident's GitHub page. So here I'm just going to copy the installer and download it into my machine. Inside the installer, you'll find a shell script that is used to launch an application called Trident Launcher. This is where the launcher application is defined. And we have 2 directories. The first directory has sample input files for interacting with Trident. So we have sample storage class definitions and sample backend definitions for Trident. We also have a directory called setup that has 2 YAML files. And these 2 YAML files correspond to the fact that you can launch Trident as a pod or as a deployment in your Kubernetes environment. In this demo, I'm going to show you how to launch Trident as a deployment. So let's take a look at the deployment definition. Here you see that Trident is defined as a deployment with 1 replica. It is important not to change this number. And the 2 containers that make up Trident deployment are Trident itself. So here the image for Trident gets fetched from NetApp account and Docker Hub. And the second component is etcd, which is data stored used by Trident internally. If we scroll down, we will see that the etcd component has a volume called etcd vol, and it is of type persistent volume claim. So if you have persistent volumes or PVs in your environment that can satisfy this PVC, launching Trident is as simple as creating the PVC and using these YAML files to deploy Trident. But if you don't have any PVs in your storage pool, which is the case for me right now, then we have an interesting situation where we need to manually provision volume for the dynamic storage provisioner. To address this problem, we wrote an application called Trident Launcher. So here you can find the definition for Trident Launcher. It uses a launcher image from NetApp, and the way it works is that it creates an ephemeral or in-memory version of Trident that doesn't persist any state. So the launcher application creates an ephemeral version of Trident and uses that to create the volume for etcd. Once the volume gets created, the launcher application creates the corresponding PVC and PV. It tears down the ephemeral version and brings up the version of Trident that has etcd and can persist state. So there are 2 prerequisites for starting the launcher application. The first one is that you need to have service accounts set up in your Kubernetes cluster. And the second one is that you need to define a storage backend that can be used by the launcher to provision the volume for etcd. To do that, you can modify some of the sample backend files that we have inside the sample input directory. I have already modified some of these files, so I'm just going to copy them over. In this instance, I'm going to use an untapped NAS backend for the launcher application. The format here is very similar to the backend config file format for NetApp Docker Volume plugin. So here we define the storage driver name, the management leaf IP address, the data leaf IP address, and the name of the storage virtual machine that is going to be used by the launcher application. So the 2 main differences with NetApp Docker Volume plugin config format is that here you need to specify the management IP address of the cluster, not for the SVM, and that you don't have to specify an aggregate. If you specify one in your config file, it will get ignored by Trident. So this storage virtual machine corresponds to this storage virtual machine that I have in my environment. And as you see right now, currently there are no volumes on my storage virtual machines other than the root volumes. So going back to, so if I want to use this backend for the launcher application, what I have to do is to copy this backend definition into the setup directory under the name backend.json, and then I can launch the Trident application. So just to show you right now, we don't have any pods, we don't have any PVC or PVs in my environment. So to start the launcher application, all I have to do is to invoke the shell script. And what this does, it creates two pods. The first pod corresponds to the launcher application itself, and the second pod corresponds to the ephemeral version of Trident that the launcher starts. So the launcher uses this ephemeral version to create a volume for etcd. Once it's done with it, it tears it down and it starts Trident as a deployment. So if I run this command again, we will see that both the launcher application and the ephemeral version of Trident have terminated, and the only pod running is the Trident pod that corresponds to the Trident deployment. And if I do a get PVC here, we will see that the launcher application created a PVC called Trident that gets mapped to a PV called Trident. And this is used by the Trident pod here. So if I want to get more information about the Trident PV, I can issue kubectl describe PV command, and we will see that the launcher application provision the volume on the NFS backend that I specified. So if I go here and do wall show again, we'll see that we have a new volume, Trident, that is used by the Trident application itself. So now that we have Trident up and running, the first step is to assign some backends to Trident. So we can go to the sample input directory or my modified version, and there I have defined 3 backends. So I'm going to use the ONTAP backends first. So as I said, the format is very similar to the Docker volume plugin format. This is the definition for a NAS backend, and this is the definition for a ONTAP SAN storage virtual machine. So again, you have to specify cluster management IP address here. So to add these backends to Trident, I can use some helper scripts, shell scripts that come as part of the Trident image. So if I want to add the NAS backend, one thing I can show you here, this is the pod definition for Trident. We can get the logs for the Trident pod by issuing this command. And here we see some warning messages here. This is because we are starting from a clean volume. The bootstrapping code in Trident that tries to retrieve state from etcd cannot find any information about source classes and backends. And this is okay because we're starting from a clean volume, so we can safely ignore these warnings. And here we have a message that Trident bootstrapped successfully. So to add these backends to Trident, what I have to do is to use these backend files to add that to Trident. So these shell scripts that you see here, these are wrappers around Trident's REST API. So in this instance, basically what we're doing is that we're posting that JSON file into the backend endpoint that Trident's REST API supports. I can do the same thing for the SAN backend. In this instance, we see an error here. It says because initiator group Trident does not exist for storage virtual machine, iSCSI, SVM1. So when you don't specify any iGroups in your backend configuration, which was the case for my SAN backend here, Trident assumes you're going to use the default Trident iGroup. And because I haven't set up the Trident iGroup in my environment, adding backend fails. So what I have to do is to come here to the UI and add a new iGroup called Trident. So now I have a new iGroup, and what I need to do is that I need to add every host in my cluster to this iGroup. So in this case, the host that I'm going to use for running the application, we can just get the host IQN by issuing the following command. So I have to add this IQN to my Trident iGroup. So now I have added my hosts. You do this step for all the hosts in your cluster so that all can mount volumes provisioned by Trident. So here I can also go show you the output log for Trident. The NFS backend was added successfully. However, the SAN backend failed because the initiator group wasn't set up. Now that we have added the Trident iGroup and we've added the host, we can repeat the failed step. And we can see that Trident has successfully added the ONTAP SAN backend here. We can check the Trident output logs, and we see we have a new backend here. And we also have a message here that says currently the Trident iGroup supports these initiators. So you can invoke these shell scripts from outside of the Trident pod. To do that, what you need to do is basically, if you look at Trident source code, there is a directory called scripts. What you need to do is to copy these shell scripts to your environment. So here I'm just going to copy the shell scripts here, and then I can invoke these shell scripts directly as opposed to invoking them from inside the Trident pod. So for example, if I want to get the list of the backends that were added to Trident, I can issue this command, and all the script does, it uses Trident's REST API, issues a REST call to get the backends that are currently supported by Trident. So in this instance, we have 2 backends. And if we want more information about a given backend, we can just use a command like this to get more information about the backend. And if we want to see it pre-printed, we can just use this shell script, and then here we see that we have an our NFS backend here. If you're interested to learn more about Trident, please visit the project page on GitHub. You can find more information about storage support in Kubernetes by following the links here. Finally, if you have any questions about Trident, please reach out to us at netapp.io/channel for containers. Thank you very much.